Dear students, today we will solve some numericals related to momentum. Before it, we should know how the momentum of a body can be changed. The momentum of a body can be changed in the following ways: by changing the direction of velocity, by changing the magnitude of velocity, by changing the direction and the velocity, direction and the magnitude, direction and the magnitude of velocity at a time. The momentum of a body can be changed either by changing the direction of a body or by changing the magnitude of velocity or by changing both direction as well as magnitude of velocity. In three ways you can change the momentum of a body, because the momentum is a vector quantity. It is the product of mass and velocity. Mass is a scalar quantity and velocity is a vector quantity. So velocity can be changed in three ways: by changing its magnitude, by changing its direction, or by changing both magnitude as well as direction at a time. Now some important points are: if V is greater than U, I mean to say that final velocity is greater than initial velocity. If a body is moving in a straight line and its final velocity is greater than its initial velocity, then the change in momentum is positive. The change in momentum is positive. If final velocity is less than initial velocity, then the change in momentum is negative. In the first case, the body is gaining momentum. In the second case, the body is losing momentum. And the third one, if the object is moving with a constant velocity in a straight line, then there is no change in its momentum. If a body is moving with a constant velocity in a straight line, then the change in momentum is zero. There is no change in momentum because either the direction of velocity or the magnitude of velocity does not change. Now we will solve some problems regarding momentum. Problem number 1. A body of mass 10 kg initially at rest acquires its final velocity. Its final velocity 10 meter per second. Find its initial momentum, its final momentum, and the change in its momentum. A body is at rest initially. Its mass is 10 kg. It acquires its final velocity 10 meter per second. Then you have to find its initial momentum, its final momentum, and the change in its momentum. Mass equals to 10 kg. The object is initially at rest, then U equals to 0 meter per second. So the initial momentum Pi equals to mass into initial velocity 10 into 0, 0 kg meter per second. M equals to 10 kg. Final velocity is 10 meter per second. Then its final momentum equals to mass into final velocity 10 into 10, 100 kg meter per second. Now the change in momentum, delta P, change in momentum, final momentum minus initial momentum. Final momentum is 100 kg meter per second and initial momentum is 0 kg meter per second. Finally you get the answer 100 kg meter per second. The change in momentum is 100 kg meter per second. Second problem. A ball of mass 2 kg moving horizontally with a velocity of 3 meters per second strikes a wall and rebounds with the same velocity. Find the change in momentum of the body. A ball is moving horizontally with a velocity of 3 meters per second and strikes a wall and rebounds. I mean to say that the ball comes back on the same path with the same velocity. You have to find the change in momentum of the body or the ball. Momentum of the ball. Suppose it is the wall. The ball is moving with a constant velocity. Mass that is given 2 kg. Initial velocity 3 meters per second. After striking the wall, the ball comes back on the same path. I mean to say that retraces, rebounds, comes back along the same path. Final velocity equals to minus 3 meters per second. Minus 3 meters per second. Negative sign shows that the path of the ball after striking the wall is just opposite to the path of the ball in which it strikes the wall. The final velocity is minus 3 meters per second. Negative sign shows that the direction of the final velocity of the ball is just opposite to the initial velocity of the ball. So, the initial momentum of the body of the ball mu, mass into initial velocity, 2 into 3, 6 kg meter per second. The final momentum of the ball, mass into final velocity, 2 into minus 3, minus 6 kg meter per second. Negative sign shows that the direction of the final velocity of the ball, I mean to say that after striking the ball, the velocity of the ball is 3 meter per second, but its direction is just opposite to the direction of initial velocity. Because velocity is a vector quantity, so the change in momentum delta P equals to final momentum minus initial momentum minus 6 kg meter per second minus 6 kg meter per second minus 12 kg meter per second. This is the change in the momentum of the ball. In the coming lecture, we will study about Newton's second law of motion, and Newton's second law of motion gives expression for measuring the force, that is F is equal to ma, mass into acceleration. Newton's second law of motion gives expression for force. Thank you.